Okay, so it's 7:05 now, so I would like to go ahead and get started. Welcome back to Intro to Geometry. This is, I believe it's class 7, and today we are going to be learning about quadrilaterals. So for the schedule, I was thinking about lecturing from 7:05 to 7:45-ish, and then take a 5-minute break. And then from that point on, we'll continue learning. And then if we finish early, we can play a Kahoot. Okay. Nope. This. Okay. All right, so as I said, today we're going to be learning about quadrilaterals. So the first section deals with quadrilateral basics. So a quadrilateral has 4 sides, 4 vertices, and 4 angles. And almost all the quadrilaterals that we study are convex, which means that all the interior angles are less than 180 degrees. So if we look down here towards the bottom of the page, we can see that there are 2 examples of quadrilaterals, rectangles, squares, basically any shape that has 4 sides, 4 vertices, and 4 angles are quadrilaterals. And if we look at figure 8.2, this is a concave quadrilateral. This is basically, it's like an exceptional quadrilateral where the angles, it's like the format of the angles are a little bit different compared to a regular quadrilateral. And if you look at the angles, not all of them are at least 90 degrees or greater. You can see that angle E, angle H, and angle F all have, angle G, all of them basically have their angles that are less than 90 degrees. So then that makes them, wait, no, yes. So then, oh, okay, actually, no, I take that back. What did I say, G? No. H and F are acute angles, so then that makes it a concave quadrilateral. Okay, so next we have diagonals, which are segments that connect the opposite vertices of a quadrilateral. So if we look at the image here, examples of diagonals would be AC and DB. So an easy way to memorize this is, diagonals, you can just figure out by the name that, oh, it's going to be diagonal, and you can see that DB and AC is their diagonal. That's just one way that I memorized I figured out what diagonals were. But yeah. And then the interior angles of any quadrilateral add up to 360 degrees. So for triangle, it's 180, but for quadrilaterals, it's 360. Okay, so we are going to be working on our first problem. So I will leave this up here this is a pretty easy problem. See if you guys can figure it out first. But I'll give you guys like 30 seconds.
Can I have a guess?
Yes.
A guess.
Yes.
It is 70.
Yes. Correct.
Okay. Just add up all the angles and then subtract that by 360 degrees.
Mm-hmm.
And then you got the angle.
Yes. So if you want to figure out angle D, as Max and Kessler figured out, it is 360 minus angle DAB minus angle ABC minus angle BCD, which is 70 degrees. Okay, next we have section 8.2, and this is about trapezoids. So a trapezoid is a quadrilateral that has two parallel sides, and the parallel sides are known as bases. So if you look at the image, we can see that WX and ZY are going to be the bases, and then the other sides are the legs. So WZ and XY are going to be the legs. So then the segment that connects the legs midpoints are called the median. And in this case, it is going to be MN. So points M and N are the midpoints of WZ and XY. Okay, so next we have problem 8.2. Looking at trapezoid ABCD, we have AB parallel to CD, angle B equals to 80 degrees, and angle A equal to 150 degrees. Find the angle values for angle C and angle D. Now, I'll leave this up here. If you guys want to take a guess as to what the answer is, you can go ahead and shout it out.
Using some of the information we already found out, we can deduct that 230 degrees, which is A and B's degrees added up, minus 360 would equal 130. So using that, we can say that angle C and angle D added up will equal 130 degrees.
Mm-hmm.
For a hint.
Okay, I think I'll go ahead and solve this problem with you guys. I won't use the whiteboard for this one because it's still not like really difficult, but yeah. So because AB is parallel to CD, we can figure out that angle A plus angle D, it's going to equal 180 degrees. So then, because we know what angle A is, we can figure out that angle D is 30 degrees. And then at the same time, we can apply that same knowledge to angles B and C. So then we can either add up angle B plus angle C to make it 180, or we can isolate angle C and do 180 minus angle B, which is 80, which is going to be equal to 100. So I'll leave this up here for like 30 seconds or 15, I don't know. I'll leave it up for just a few moments. Okay, I'm going to move on. So, oh, is the answer? Yes, that is the answer. Here, let me, sorry, I'm gonna exit out really quick and make sure that the answer does not show up. So just pretend that you guys cannot see the answer. Okay, that should work. All right, so problem 8.3, in trapezoid ABCD, AB is parallel to CD, diagonals BD and AC meet at point N, and the lengths of BN, CN, DN, and CD are given, and we want to find AN and AB. So I'll leave this up here. Okay, I'll go ahead and walk through this problem with you guys. So, okay, because we have parallel lines, we can deduce that there might be similar triangles. So since AB and CD are parallel, that means that triangle ABN is similar to triangle CDN. So that means that we can set up the following proportion. AN, so AN is right here, over CN is equal to DN over DN, which is going to be equal to AB over CD. So we just set up proportions that correspond to the different sides of the two similar triangles. So then since BN over DN is equal to 1/4, because we have 4 over 16 and then we simplified that to 1/4, AN is going to equal CN over 4. So we know what CN is, which is 12. Plug that in and we get 3. And AB is going to be equal to CD over 4. We know what CD is. It's going to be 20. Divide that by 4 and we get 5. So I'll leave this up here and then we can move on. Okay, so I think we can move on now. Okay, so next we have important information. The trapezoid's median is parallel to the trapezoid's bases and equal lengthwise to the average of the bases' lengths. Okay. So next we have the area of a trapezoid. So for the area, what I usually do is I actually do 1/2 times height times A plus B, but you can also use this formula where height H is equal to the height, divide that by 2, and then you multiply that by A plus B. So A and B are going to be the bases. Or yes, yeah. Okay, and now we have more about trapezoids. So base angles are the two trapezoid angles that share one of the trapezoid's bases as a side. So, okay, isosceles trapezoid is a trapezoid where two base angles are equal. And in an isosceles trapezoid, the base angles are in two pairs of angles with the same measurements, and the legs and diagonals are equal. If any one of the smaller statements above is true for a trapezoid with exactly a pair of sides that are parallel, then all the other statements must be true for that same trapezoid.
Can you leave it on there for a little bit?
Yes. Okay, I will move on now. But this information is going to be sent to you guys in an email after class. So if you guys want to refer back to this information, you will have access to it. Okay, next we have problem 8.8. So given that GHIJ is an isosceles trapezoid with GH equal to 8, HI which is equal to GH, which is going to be equal to 6, and IJ equal to 10, find HJ. So I'll give you guys a few minutes to try to solve this problem.
The larger dimension and diagonals are equal, so wouldn't that mean that HJ could equal 8?
HJ.
Not quite.
Okay.
Okay, I'll go through the problem with you guys. That was a good guess, though. Okay. Let me upload an image. Oh, just give you guys a heads up, I can't see the chat. So if Adrian is there, he will answer the questions. And if he's not there, then I believe Cloud Classroom will answer the questions. Chapter 8. There we go. Okay, we're going to place the image there. So, let's see, we wanted to find HJ. So, first, let's see, we want to, okay, so we wanted to draw the altitudes GY and HX. The problem already did that for us to build the right triangles. So this means that GY is going to be equal to HX and GJ is going to be equal to HI as seen with the values. So then triangle GJY is going to be similar to triangle HIX, and I will write that down. Triangle GJY is similar to triangle HIX because of hypotenuse, leg congruence, and I abbreviate congruence as Kong, so just to give you a heads up. So then this means that JY is going to equal XY. So next, we can figure out that YX is equal to GH because GY is parallel to HX and YX and GH are the distance between GY and HX. So this means that YX is going to equal 8. I'll just write it here. And GY, which is equal to XI, is going to equal 10 minus 8 divided by 2, which is equal to 1. So there's GY and there's XY, and then just did simple math there. Okay. Next, we want to find HX from triangle HXY. Oh, HXI, sorry. So we can use the Pythagorean theorem for this. So we'll know that HX is going to be equal to HI squared minus the square root of HI squared minus IX squared. I just skipped over the steps of isolating HX. And then if we plug in numbers, we're going to get the square root of 36 minus 1, which is going to equal the square root of 35. So then we can use the right triangle HXJ to get HJ. So then HJ would equal HX squared plus XJ squared. And then we just have to plug in values. So then hx squared, we know what that is, so we just square this, so then we would get 35. And then xj, we know that that is going to be equal to 9 since this is 1 and 1, so then square that to get 81. So then you would get the square root of 116. Simplify that to get the square root, or 2 times square root of 29. So that would be the final answer. And I'll leave this up here for a minute. Okay, so it's been about a minute, so I will go back to the slides. Okay. So next we have 8.3, which is about parallelograms. So parallelogram is a quadrilateral that has two pairs of opposite sides that are parallel. So quadrilateral ABCD is a parallelogram since AB is parallel to CD and AD is parallel to BC. And notice how there are two different parallel or marks that show that AB and CD are parallel, and then AD and BC are parallel. So this shows
So
that,
in order that AB is parallel to CD and AD is parallel to BC, the length of CD and AB is going to be the same distance to each other, and AD and BC are going to be the same length as well, right?
Or they're going to be, you know, two different sets, like two pairs of different parallel lines, or parallel segments, I should say. But yes, so AD and BC would have the same lengths, and then AB and DC would have the same lengths.
Can I say something?
Yes.
The two most common parallelograms are squares and rectangles. Those are the most common.
Yes. Okay, so next we have problem 8.9, and we want to find x, y, and angle B in parallelogram ABCD shown on the right. So I will give you guys a few minutes, or a minute or so to do this. This is not too difficult. And I'll also be right back in like 10 seconds. Okay. Okay, so I will go ahead and go to the whiteboard.
Good job for everybody.
Oh, did they figure it out? Or no? Yes?
We solved it in the chat.
Okay. Okay, well, if you solved it in the chat, then I will just present the answer. Okay. So AD is parallel to BC, so we have angle D plus angle C, which is equal to 180, and angle C is equal to 150 degrees because we know what angle D is. And also angle B plus angle C equal 180, so angle B equals 30 because we know what angle C, or no. Yes, we know what angles, what did I say? Or yeah, angle, so you would plug in, yes, you know what angle C is, sorry, my bad. So 3x would equal 30, and then you get x equals 10 degrees. And angle A plus angle D equals 180, so angle A equals 150. And x plus y equals 150, so y equals 140. Sounds like you guys solved in the chat, so I'll just leave this up like really quick, and then we can move on. Okay. So next we have problem 8.10. Prove that if AB is equal to CD and AD is equal to BC, then ABCD is a parallelogram.
That means angle A equals angle D and angle B equals angle C.
Mm-hmm.
Maybe. Or angle A equals angle C and angle B equals angle D.
Yeah, it depends on how you draw it and how you label it. Okay, so I'll go ahead and go over this problem. So here is the parallelogram. And so what we would do is we would cut ABCD into two triangles by drawing AC. So knowing that AD is equal to BC and DC is equal to AB and AC is equal to AC, we have triangle DAC is congruent to triangle BCA by SSS congruence. So then angle BAC is going to be congruent, or it's going to be equal to angle ACD, which means that AB is going to be parallel to CD. We also have angle DAC is going to be equal to angle ACB, so AD is going to be equal to BC, and therefore ABCD is a parallelogram. So I'll leave this up here for a few seconds, and then we can move on. Okay, so I'll go ahead and go into the next slide. So we're going to learn more about parallelograms. In parallelogram ABCD, the opposite sides are equal, the opposite angles are also equal, and the diagonals bisect each other. ABCD is a parallelogram if any one of the following are true. AB equals CD and AD equals BC. Diagonals AC and BD bisect each other, and angle A is equal to angle C and angle B is equal to angle D. If you prove one of these statements, then the other statements must also be true. So go ahead and take a look over this, and then we can quickly go back to the previous image to just get a reference about, to just apply the statements to an actual image. Okay, So for the first statement, AB is equal to CD and AD is equal to BC, we can see that that would apply. So then therefore this would become a parallelogram. For the second statement, diagonals AC and BD bisect each other. So imagine that there's, okay, so we have diagonal AC. Imagine if there's another diagonal here. Because they bisect each other, that would be a parallelogram. And angle A is equal to angle C, and angle B is equal to angle D. So we have opposite angles A and C and opposite angles B and D. They're going to be equal to each other. Therefore, ABCD is a parallelogram. Okay, so next we're going to learn about the area of a parallelogram. So area of a parallelogram is actually pretty simple. It's just base times height. For example, if you look at the image here, the area of ABCD is going to be AB times XY. You can also look at it from another way. If you want to tilt your head sideways and then see it from, I guess, like a horizontal view. So BC times PQ would also work to figure out the area. I'll leave this up here for a few seconds and then we can move on. Okay. So next we're going to learn about rhombi. So rhombus is a quadrilateral where all of its sides are equal. So if we look at this image here, we can see that by the tick marks, all of the sides are equal to each other. Therefore, it's a rhombus. An example of rhombus could be a square, because all of the sides of a square are equal to each other. A rectangle would not be an example of a rhombus because it has two sets of equal sides. Not all the sides of a rectangle are equal, so it's not a rhombus. Every rhombus is a parallelogram, meaning that all information that is true about parallelograms is also true for all rhombi. However, every parallelogram is not a rhombus. So if you think about it, yes.
I have a little question.
Mm-hmm.
Is the way you calculate the area of a parallelogram the same as you do with squares and rectangles?
Yes. So it is, yeah, it's just base times height, and that's what you do for squares and rectangles.
So that's because you could cut one. That's because you could cut one. You could cut one part of it and then bring it to the other side.
Mm-hmm.
A rhombus could be like a rectangle or anything.
The area of a rhombus is a bit different. But for parallelograms, yes, you can. Let's see. Let's go back to an image of, okay, parallelogram. Let's say you can cut this part and then bring this part to over here, so it would actually form. It could form it would form a rectangle in this case. But yes, so as you were saying, you could cut this part, bring this over here, and then because of that, the area of a parallelogram is base times height. But then for a rhombus, it's a little bit different. The area of a rhombus is 1/2 times AC times BD. So you're actually multiplying the diagonals of the rhombus to figure out the area. But,
okay, I got it. And okay, sorry, I just messed up.
No, you're good. Don't worry. Ask if you have any questions. Feel free to ask. Don't be afraid. You can also ask in the chat too, of course, because Adrian is, or whoever's helping with the chat will answer your questions too. Okay. Oh, so I don't know if I finished this piece of information, but so every rhombus is a parallelogram, but then every parallelogram is not a rhombus because parallelogram has two sets of parallel sides, while rhombus, all these sides are equal to each other. So if the parallelogram actually has, it can have two sets of parallel sides, but then if the parallel sides are all equal in length, then that can become a rhombus. But a rhombus, that's only the case if all these sides are equal to each other. For example, this parallelogram cannot be a rhombus because the two sets of sides are not equal in length. Okay, I'd like to move on to the next slide, and we're going to be figuring out problem 8.14. So ABCD is a rhombus where AC is equal to 30 and BD is equal to 16. Find AB and the area of ABCD. So I'll leave this up here and see if you guys can figure it out. If somebody wants to let me know, like verbally, that you guys have figured out in the chat, then we can just go ahead and just go over the answer. But if people are trying to figure out the answer still, then we can of course go to the whiteboard and figure it out over there. Okay, so I'm not hearing anybody trying to maybe take a guess as to what the answer might be, so I'll just go ahead and work on the problem on a whiteboard.
I don't think it's space times height because
Yeah, it's not going to be big. Yeah.
It's base times height divided by 2.
Or it's the
Yeah.
diagonals.
So the area of ABCD is 120.
Close. Pretty close. That's a good guess, I would say. Let's see, what number problem? Remember the area of a rhombus? Here, we can go back if you guys want to. Area of a rhombus is 1/2 times AC times BD, so it's the diagonals that you're multiplying. It's not these sides. Don't, just a heads up, don't confuse the area of a rhombus with so here I have ABCD. Decrease the size of it a bit and then place it. So let's see. So okay, I'll just write down the information that we know. So we know that AC is equal to 30 and BD is equal to 16, and we want to find AB and ABCD. So ABCD is simple because we know what the diagonals, the lengths of the diagonals are, so that's going to be AC and BD. So the area of ABCD is going to equal 1/2 times 30 times 16, which is going to be equal to 240. Okay, so that was pretty simple, right? Okay, next we want to find AB. So let's start with the diagram and let's just look through it. So all sides of ABCD are congruent because it's a rhombus, and the diagonals bisect each other. And if we can see like the different tick marks of each triangle that's formed, we can figure out that they have congruent sides based off of the tick marks. So this means that the four triangles are congruent by SSS congruence theorem. And all four of the angles at X here are going to add up to 360 degrees. So this must mean that the four triangles are right triangles, meaning that the diagonals are perpendicular. So the right triangles are going, let's see, okay, BD, because we know what BD is, so it's going to be 16. We know that DX, for example, is going to have 8, and BX is going to have 8. So then at the same time, if we just use a similar method, so we use AC, if we split up 30, divided by 2, that's going to be 15, so then this is going to be 15 and 15. So then from this point, we can use Pythagorean theorem to figure out what AB is. I can write it out, but you guys might have noticed that 8, 15, and blank is the Pythagorean triplet. So, I mean, here I can just write it out too. But it would be 8 squared plus 15 squared equals AB. So then you square root. And then, let's see, AB would be equal to 64, let's see, what's 15 squared, 64 plus 225, that's going to equal 289. If you square root that, you should get 17. So the answer is AB is equal to 17, and the area of ABCD is equal to 240. So I'll leave this up here for a short amount of time. Oh, and it looks like we can take a break soon, or break after this. Here, I'll just, okay, once it becomes 7:49, I say we can take a 5-minute break and then continue on from that point with our lesson. Okay, so break time. Come back in 5 minutes and then we'll resume our lesson.
Reminder, try to learn everything as fast as possible because we really do want Kahoots. But the lesson isn't just for the Kahoots.
Yeah, so do I.
Well, we're actually a whole class ahead at the moment, so we really don't have to finish the lesson by the end of class. So we can learn for maybe, I could say like, we could start the Kahoot at 8:15. So we can learn for like maybe 20 more minutes-ish, and then we can play Kahoot at the end.
So have we solved it?
Yeah, no, I'm just I can go back to the presentation if you want me to, but yes, we have solved the problem, or unless you're referring to something in the chat.
What?
Okay, so it's 7:53 now, so we can go ahead and continue on with the lesson. And then, as I said, around 8:15ish, maybe 8:10 even, we can go ahead and start playing a Kahoot. Okay, so next we're going to learn about rectangles. A rectangle is a quadrilateral in which all interior angles are right angles. So if you look at the image below, you can see that all the interior angles are right angles. And opposite sides are equal in length, so you can see that by the tick marks, the opposite sides are equal. And the diagonals of a rectangle are congruent. So if there were imaginary diagonals here, you can see that they would be congruent. Okay, so next we have problem 8.18, and we want to find the length of a rectangle's diagonal given that the perimeter of the rectangle is equal to 44 and one side length is equal to 10.
So we can say that so if one side length is equals 10, so then the other so that there's another side that's 10, so that's 20 in
So
total.
that's 20. Let's just subtract that by 20 and then we get 24. So
and yeah, then divided by 2 we get 12. Correct?
Yes.
Okay.
And then we want to find the rectangle's diagonal. So we found the size of the rectangle, but now we want to find the diagonal. Okay, so I will go ahead and pull up the answer. I'm not going to use a whiteboard. I was going to, but looks like you guys are pretty on top of things. So the last part of it is you would use the Pythagorean theorem to find the measurement of the diagonal. So in this case, it would be xc. So xc would be equal to the square root of, you would plug in 10 here, squared plus, and then you would plug in 12 here, squared. So then you get square root of 100 plus 144, which would equal 2 times square root of 61. So that would be your answer. Just to give a heads up, I can't find a way to incorporate the square root sign. So then I just abbreviate it and I use square root and then parentheses to show that the numbers inside the parentheses should be under a square root. So that was pretty straightforward. I'll leave this up for like a few more seconds and then we can go ahead and move on to the next slide. Okay, So let's see, rectangle. Okay, so this is more about rectangles. The diagonals of a rectangle are congruent and are equal to the square root of the sum of the squares of the rectangle's length and width. So that was a lot. I would say that's like quite a few words, but examples always help. So to apply this to the example, QS is equal to PR, so that is going to be equal to the square root of QR squared plus SR squared. So that's actually just applying the Pythagorean theorem, which is what we just did in the previous problem. Okay, so that was pretty straightforward, so I will go ahead and move to the next slide. So next we have problem 8.19. So for this problem, we want to prove that the quadrilateral created by connecting the midpoints of a rhombus's sides is a rectangle. Okay, so I will go ahead with the problem. So I'm not a great drawer, so I just included an image of the rhombus and then the rectangle inside the rhombus. So first, we want to draw the rhombus ABCD and let EFGH be the quadrilateral that we formed. So we want to prove that EFGH is a rectangle, so we have to look for a way to find the measures of each angle of EFGH. So the vertices of, this is midpoint, I abbreviated it, are midpoints of ABCD, which is the rhombus. So the vertices of EFGH divide the sides of ABCD into 8 equal segments. So we can see here 1, 2, 3, 4, 5, 6, 7, 8 equal segments. ABCD is a parallelogram, so angle A is equal to angle C, and angle B is equal to angle D. Therefore, triangle AEH is congruent to triangle CGF, and triangle BEF is congruent to triangle DGH. And each of these triangles, they're isosceles triangles, so then we want to let triangle AEH equal to X and triangle DGH equal to Y. So then we want to identify the equal angles. So each angle of EFGH is going to be equal, oh, sorry, okay. I meant to say let triangle, let angle, sorry, not triangle, let angle AEH equal to X, and then let angle DGH equal to Y. Sorry, that must have been confusing. But to continue where we left off, so each angle of EFGH is going to be 180 minus X minus Y, because we know that these are straight lines, so they would form 180 degrees. Thus, the angles of EFGH are equal, so then EFGH must be a rectangle. So I'll leave this up for about 30 seconds, and then we can move on. Okay. So next we're going to learn about squares. So a square is a quadrilateral where both all sides are equal and all angles are equal. There should be an R in there. let S equal side length of a square, PM equal perimeter, and A equal area. So these are just abbreviations for the following formulas. So perimeter would be equal to S plus S plus S plus S, or 4 times S, and area would be side times side, so then that would be side S squared. So then drawing a diagonal would create two 45, 45, 90 triangles. And we want to let D equal the length of a diagonal. So then we would have D equal to side times square root of 2. And then perimeter would be equal to diameter times 2 times the square root of 2. And area would be equal to diameter squared over 2. So this is basically incorporating, if we know what the length of a diagonal is, we can use that value that we know to figure out the perimeter of area. So this is these conditions, or these formulas would be used when we know what the diagonal measurement is. So I'll leave this up here for about a few seconds and then we can move on. Okay. So next we have problem 8.22. So ABCD is a square. The circle with center A and radius AB meets AD's perpendicular bisector in 2 points, where O is the one inside the square. Find angle AOC. So this is, I would say it's a bit more of a difficult problem. Okay, so I will now go ahead and go over the problem on the whiteboard. So that is problem 8.22. So our goal is to find angle AOC. Okay, so we want to draw OD. So that we can try to use triangles and see if we can figure out what angle AOC is. So pretend that's a straight line, but OD would split angle AOC in half, or it would, I'm not sure if it's split in half, but it splits AOC. And then we can figure out that triangle AOY is actually congruent to triangle DYO by SAS, because let's see, these angles would be congruent, and then we have these two angles are, if this is 90 degrees and this has to be 90 degrees, and then they share the same side. So then it would be SAS. So I would go ahead and write that down. Triangle DYO, and then parentheses SAS. So then this would mean that AO would be equal to OD, and AD is going to be, yes, okay. So then this would also mean that, or we can figure out that AO would actually be equal to AD, because if we were to, That's a terrible circle, but if we were to draw out the whole circle, we can see that they are both radii of the circle. So then this means that triangle AOD is actually an equilateral triangle. So then this would mean that that angle AOD is 60 degrees. So we'll just write that down. And now we want to find DOC because we've already found AOD. So okay, next let's write find angle DOC. So OD is side length of the square. No. OD, sorry, is the side length of the triangle. So then OD, I don't know. Yes, okay. So OD is the side length of these. Okay. Sorry, okay, my apologies. So if we actually look at triangle DOC, we can figure out that because DO is equal to AD, and AD is the side length of the square, this means that DO must also be equal to DC. I can't draw down there, so just imagine that there are two tick marks. So then OD would be equal to DC, and this would mean that DOC is actually an isosceles triangle. So angle DOC would be equal to angle DCO. Can I draw? Yes. So I will draw 2 to show that those two are congruent. So we already know that angle ODC is equal to angle ADC minus angle ADO. So then if you plug that in, that would be 90 minus 60. So then we would get 30 degrees. So then from triangle DOC, you write that, you would have angle DOC plus angle DCO plus angle ODC would equal 180. So then 2 times angle DOC plus 30 degrees would be 180. So let's write that down. 2 times angle DOC plus 30 equals 180. So then we can figure out by doing math, 150 divide 2 by both sides, angle DOC would equal 75. So now that we know that DOC is equal to 75, we would just add up 60 plus 75, and then we would get 135. So this is the measure of angle AOC. Sorry, that was messy, but we got to the solution. So I'll leave this up here for maybe 30 seconds, and then we can move on. Okay, that was, I don't know if that was 30 seconds, but I think that was enough time to go over the problem. Okay, so I believe that, oh no, we actually have another section, but we can go over the last section in our next class because we'll play Kahoot in a few minutes. But this deals with if and only if statements. So An if statement is, for example, an animal has 4 legs if it is a cat. However, an only if statement is a bit trickier. So an animal, ignore the S, has 4 legs only if it is a cat is false. So math statements use both if and only if together. For example, a month has fewer than 30 days if and only if the month is a February. Equivalent to the following statements would be, every month with fewer than 30 days is a February, and every February has fewer than 30 days. So to prove an if and only if statements, you must actually prove the 2 different statements first. In order to prove that a statement is true, you must have a proof that covers all possibilities, and to disprove a statement, you just have to find one case where the statement is false. So in math, if you want to prove something that's true, you have to make sure that all the possibilities that might come out have to be true. If there's even a single statement or single possibility that turns out to be false, then there's no way that that statement or whatever you're trying to prove can be true, because there's one possibility that's actually proving that no, it's not true. Okay, so I'm just going to, because we're dealing with if and only if, I'm just going to go over it with you guys, because I feel like these are a bit, this concept is it's a bit different, I would say. But for problem 8.23, we want to prove that ABCD is a parallelogram if and only if angle C is equal to angle A and angle B is equal to angle D. So we have a parallelogram here. So first, we actually have to prove our 2 statements as we previously said. First, show that ABCD is a parallelogram if angle A is equal to angle C and angle B is equal to angle D. So if we add up all 4 of the angles, we get 360 degrees. And we know that angle C is equal to angle A and angle D is equal to angle B. So then we have 2 times angle A plus angle B, because we're substituting the angles since they're congruent to each other, to get 360 degrees. So angle A plus angle B equals 180. Therefore, this means that AD is it's parallel, ignore angle, it's parallel to BC. So since angle A is equal to angle C, we have angle B plus angle C equal to 180. Therefore, AB is parallel to CD, and ABCD is a parallelogram. So then now we have to show that ABCD is a parallelogram only if angle A is equal to angle C and angle B is equal to angle D. So because ABC is a parallelogram, AD is going to be parallel to BC, so angle A plus angle B is 180 degrees. AB is going to be parallel to BD, so angle B plus angle C is going to be 180. This means that angle A is going to be equal to angle C. Similarly, angle B is equal to angle D. So we just proved the 2 statements, meaning that we can say that ABCD is a parallelogram if and only if angle C is equal to angle A and angle B is equal to angle D. So that is how you would prove an if and only if statement. Okay, so we can stop there and we can go ahead and play a Kahoot now. Okay. And in the future, there is going to be one class session where we will probably play more Kahoot. Yes?
I have a, can we play a team versus team?
Wait, hold on, I have to turn down the music. What did you say? Sorry.
Could we turn, go team on team or no?
Oh, do you want to do teams?
Who wants to do it anyways?
I wanted to, like, we do it all together and then we just solve it.
Okay, so if you guys can just all be in the same team, if that's what you guys want to do.
I think that will probably be, why don't we just do it until like 2 groups, each with 7 people, or 6, something.
Okay.
And besides, you can't decide which team you're on, so there's 7 teams.
Let's just work together and then choose the right answer.
All right.
Who wants to join the Golden Dragoon?
If you guys just also, there might be people out there who just want to like follow on. They might not, I guess, might not want to play, or okay, we have one team, Team E, nice.
My name's up. They're on me.
But why aren't we hearing the music?
I mean, we can play the music. The problem is, if I turn up the music too loud, then I actually can't hear you guys.
I don't know how to go into a team.
Oh.
Okay, let's just start.
I'm not
Free. I'm not
creative.
not creative junior. Wow, that's so cool.
Were you able to join a team or no?
How do you join a team?
How do you actually do the read?
Wait, first of all, how do you join a team? Can somebody tell me?
If somebody can help him, that would be.
You just type in a random name and then just.
No, but then only be you in the team instead of like with other people.
Let's just start.
I'm confused.
Oh wait, so then
confused.
would you have to physically be together to form teams?
Oh, like you're in the team and then you're.
Okay, let's just do that. We need to beat the other team, so let's just work together. Let's just go first.
It looks. I think you have to actually be physically with each other in order, because you're sharing one device. That's why it's called a team. So I don't.
Let's just start.
Like, let's see.
Come on, let's just start.
Maybe it's not such a good idea.
Okay, you can just enter yourself as a team,
Okay.
and then because looks like people already signed up for it, so just pretend that you're in a team, even though you might not be in a team. So just, you can enter random names. I'm not creative junior. That was smart.
That's really funny. Should we start?
Okay, we can, yeah. I mean, it looks like people.
Wait, I haven't even got in yet.
Okay, we can wait. If there are people who want to.
That's very funny.
Were you able to get in? Or. All right, okay, great, nice. So is everybody ready to play, or are there more people who want to join?
Yes, I am the green toucan, number 1.
All right.
That's
Okay,
so
so
funny.
Go ahead and get started.
Come on. I can't wait. Yeah, just for once.
Green is my favorite color. Toucans are my favorite bird. But not because of the Fruit Loops.
Let me see.
Fruit Loops.
Me neither. I don't like Fruit Loops either. I don't like Fruit Loops. They're not as tasty as fruits. The interior of
Here's something to ruin everybody's
you know
childhood.
what?
Fruit Loops only have one flavor.
Yeah, but fruits have many flavors. You know the sum of that. Come on, let's just choose it.
All
Yes.
right. So
Yeah.
the angles, we have talked about this
Hey.
before. Good
Oh.
smiley face. But
Okay, let's see. What's the value of x? I could just answer it, but
remember, Max, we want to keep this to ourselves because it's more of a.
I'll just give you a tip. Add the angles you know, and then subtract it by the sum, by the you know what.
I got it wrong immediately. I slipped.
Oh no.
You got, because you didn't. You just need to add those two angles and then subtract it by the you know what, and then you got the minus answer, and then you just multiply it by -2, and then you just multiply it by -1, and then it would become positive.
Smart method.
That's just funny.
Okay. Oh, press skip.
Let me calculate it on my calculator. It's really hard because I'm just in the first grade.
Okay.
Okay, I'll just. Oh my god! Just 78.
Well, I don't. Looks like one team isn't answering, but
200 and
wait until if they submit an answer.
100 minus. So what's the sum of it? Let me. Oh.
Two people got 69 and two.
Sorry. I thought the sum was 360. I just typed in the wrong number.
You would add 78 plus 43 and get 121. Subtract 180 minus 121 to get 59.
Just say that. Is that so? Okay. What's the value of x? Again? No, that's not. X.
I can't see the number.
Oh, I know the x. You just have to.
Hey there.
The x is equal to you know what?
So that's 45.
Is equal to 45 plus.
Minimize the screen.
There you go.
X equals 45 plus the you know what angle.
So this angle up here is 45, and you want to.
And I want it 90, and then choose it. It's 45 plus 90. That's equal to 130. I'm not saying that. It's the 135. Sorry, I just get that one. Sorry.
Max, try to keep the answers to yourself, because this is a competition. A friendly competition.
Okay, got it. Just wanted to share.
You can do it in your brain.
I was doing my brains. Am I brainstorming, and then when I don't think I will.
Green toucans must win. Because first of all, they're green, and toucans are the best birds.
Okay, I'm gonna go ahead and skip.
Is that you hit one? You hit two with one small, or
So, you would have done?
Get one bird.
What you would have done is, this is a straight line, so then 180 minus 45 to get 135, because that's 45. Yep. Okay, so next. Good job, Eve.
Okay.
Green toucan.
Let's see, the next was just give you a tip. Next time I'll not say the answer, but just give you a tip.
Okay, so what statement is true about the triangles? Here, I'll blow it up. Okay, so here are the triangles.
Oh, let me calculate it.
Okay.
I'm not sure if I'll say if you calculate and plus it by no, they're the wrong way. If you add and
Okay. So these triangles are not congruent because in a congruent triangle, the sides and the angles would be equal. However, if you look at the two triangles, you can see that the angles are the same, but then the sides are completely different. So then the triangles would be
180 minus 180 minus these two, the sum of. That's pretty easy. Just I'll solve it on my own, but I won't give it to you. I just solve it.
I'm angry.
Let me see.
I'm angry. The green two cons are not winning.
That's because you don't have a calculator because it's really hard. But I have one.
Just yeet your calculator out of the window. Seriously, just yeet your calculator out of the window. You don't need it.
Yeah, but I'm just in the first grade, so I need it.
okay. Parallel
Okay,
lines
I'm sure
are
because I'm really good at math.
Can you maximize the picture?
yes. There we go.
Oh.
Okay. So 1, 2, 3, 4, 5, 6, 7,
1
8.
equals 2 equals 5 equals 6 equals. Okay, let's see it. Oh, which statement is true? I choose all of them. I would choose all of them. But I'm not sure if it's all right. I'm not sure.
Only
There might be
one
some
is
catch.
the
Oh yes,
right
they.
answer.
Oh yeah, there are some catches. Okay, I'll just delete one of those. I'll choose all 3 of the answers except one. It's you will, and then I'll choose all 3, but then I'll left one. Yeah.
So if you look, angle 2 and angle 6 are going to be
They're
coordinate angles. So
because
they're
they're
going to be,
line.
yeah, going to be equal to each other.
Yeah.
All right.
What type of triangle is this?
So
Oh. Oh.
Oh. Is this? Wait. Need a calculator. 180 minus
But it's obvious.
minus the 2 numbers. Minus the 2 numbers, but I won't tell you.
there's 16. There's 5, right?
You need to do that.
Are there 16s now? I guess, okay. I guess there's 16s. I thought there's 5.
I think it's. You need to figure out what I said. Yeah. I already had that in mind, but you need to figure out what I said. I didn't say it, definitely. But I just said it in a little, in just a little voice, so you won't hear me. Yeah, really. Are you serious? No. I already had that one in mind.
7,
Not sure you're going to pick the same one.
4, 3.
I'm sure that I'm right.
Okay.
Yes, I'm right. I'm right.
So
Yes,
if you did the math, 76 plus 28, you could subtract that. Or
And
okay, so
mine is
46 plus 76 would have gotten, you would have gotten 104. Subtract 180 minus 104 to get 76. So then that means that
that's
this
I
is
saw.
Yep.
Because
All right, let's go. The green two cons are now in fourth place.
it's really hard, so I need a calculator.
triangle is shown between two
Just that one.
Okay. What is the value of x?
A triangle is shown. The value of x. Oh, really hard.
So you want to find x, 50, 100. Okay.
You max out now.
Yes. There you go.
Oh, that's hard because can't really calculate. Wait, I could do it in just some way. I could do it in some way, but it's the two lines. Oh, they're parallel. That I could solve it.
You
I
need
got
to mute, or else
I got it,
everybody's going
but I
to
won't-
listen to you.
I didn't use the calculator. I promise.
You need to just mute yourself, or else everybody knows.
But I didn't say it.
You did.
Did I say it? What's the
You
answer?
just lost Max.
What's the answer, Violet? What's the
Your
answer?
hint is literally the same thing, the same level as just yelling out the answer, because now everybody knows.
I just do it. I know it, but I didn't tell you that. I won't see anything from the next one because I'll see it, but I'll mute myself so that you don't know what I'm saying.
Oh. Okay.
One got it right.
So this would be 30 degrees. And then because it's a parallel, this angle and this angle, they're going to be vertical. So if you know that this is 30 degrees down here, then you would do 180 minus 30 to get 150. So that's how you would get to the solution. Okay. Here is the triangle. X 40, 60. Okay.
Can you just shrink that one?
There you go.
Yeah, I didn't say it. Still didn't say it.
Oh,
Honestly. Sure to Jesus. I said to Jesus.
Okay, I'm going to skip when it goes down to 60 seconds.
I kind of got it.
Three, two, one. All right. Okay. So the answer was 80. What you would have
Got it
done.
right.
So if you know that these two lines are parallel, then this must be 60 degrees because they're corresponding angles. So then you would do 180 minus 60 plus 40, which is 180 minus 100. So then x would be equal to 80.
Lizzie, I have a little question.
Yes.
Can I say the wrong answer and then let all the rest of them?
Just keep the answers to yourself,
Okay.
Max. Just
Okay, just
don't
keep
say
it to my mind. Just do that. I promise to Jesus.
and This one's a bit trickier. So I'll click skip when it goes down to 15 seconds. Three, two, one.
Ooh.
Okay, they
This-
have to be similar but not congruent. So if two triangles have two angles that measure the same, so let's say that M was like 20, and then N
Yeah.
was
Yeah.
60 or something.
This is
This
kind of
is
hard.
the
So I
first
didn't
time
get it.
This is the first time nobody got it correct.
So basically, remember that in a congruent triangle, all of these sides and angles have to be congruent, but when two angles in two different triangles, when two different triangles have two angles that are the same, that doesn't necessarily mean that the triangles also have congruent sides. So that would, if you have two angles that are measured the same in two different triangles, then that proves that it's similar, but it doesn't prove that it's congruent. So then they have to be similar, but it doesn't necessarily mean that they're congruent. They can be congruent, but because you can prove that they also can't be congruent, then this would be the correct answer.
Can we play another round?
So it's actually, we went 8 minutes over class. Class is supposed to end 8 minutes ago.
Why can't we?
Read. This one is
Nice job, Eve.
E.
Great job.
I'll take.
Oh.
Yay! Green toucan.
Okay, so we can definitely play. We can definitely play another one next class. But thank you all for coming to today's class, and we will see each other next time.
Okay.
Bye.
Same as always.
Have
See you,
a
ma'am.
good night
Same
or
as
good
always.
morning,
That's my-
wherever you are.